Here is the first part. The VCC is the power supply, and I have to switch S1 and S2. When I push down the button, they allow the user to provide a high logic to the gate, and the resistor R2 and R3, they are the pull-down resistor, ensure that the input to the gate are at a non-low state. And the R1 is the current limiting resistor for the LED to ensure that it won't be damaged. And I have another LED. It shows the state of the output from the gate. It lights up when the output is high and turns off when it's off. Turn off when it's low. So for the first one is the NAND gate. So it means that if the input is 00 or 10 or 01, the output are all 1, the lights will on. And if the input are both 1, the output will be 0. And the second part, we change the NAND gate to a NOR gate. So the logic is the input is 0 and 0, the output will be 1, the LED will on. And if the input is 10, 01, or 11, the output will all be 0 and the light will off. And here is the third part. We have 3 NOR gate now. And if we talk about if we want the light is on, so we need the U1A output be 1. So the two input will be 0 and 0. It means that we want U2A and U3A. The output are all 0. So the input to the U2A and the input to the U3A, we can have 10, 01, or 11. And these three options, the output are all be 0. And here is the fourth part. 5 DC power is the power supply to the logic gate. And we also have a push down button as one. Button, it can serve as an input device to the logic gate. When I press the button, it changes the state of one input to the gate. I also have the function, the generator is a 10 Hz wave. It provides a cascade clock signal to one input of the logic gate, and the signal between high and low at a frequency of 10 Hz. And for this one, we have the NOR gate, and the LED are also, it shows the state change. When the gate's output is high, like is 1, the LED turns on, and when the output is low, when it's 0, the LED will off. The resistor, a 200 ohms resistor, is a current limit resistor to prevent the LED damage. And that we also have a 330 resistor after push the button. And I think it's also a current limiting resistor for the logic gate input. So when we talk about if we want the LED turn on, it means we want the output is 1. So for the NOR gate, we want the output is 1. So we need both input are 0 and 0. When we didn't put down button, and it will the one input will be 0, and the second one function generator. When the wave is high is 1, and when the wave is low it will be 0. So if I push down the button, I start this one. It fly is now. So if I push down the button, it means that one input is 1, and another input will be 1 and 0, 1, 0, 1, 0, 1, 0, like the wave be high or below. So when the input is 0 and the other input is 0 or 1, the one input is 0 and another one is 0, 1, the output will be 0 and or 1, so it will flash. And the same we have this one, the gate we change to the another gate. So if we want the light is on, we can change the input 0, 0 or 1, 0 or 0, 1. So now we have the function generator here. The input is 1 or 0. So if I didn't push the button, let us check it. So yeah, so like that, if I didn't put on button, the input of U to A is 1, 0, and another one, it can be 0 or 1 because of the function generator wave. So when the input are 0, 0 or 0, 1, the output is 1. So it continue light, it continue on. But if I put down the button, this it will be 0 of the first input, and the function generator is 0, 1. So it will flash depends on the generator wave.